Let's go to Lico 276 paint fence. And for this question, give us an post in k different colors. And you must paint the post. Every post must have exactly one color. And there cannot be 3 or more consecutive posts with the same color. And ask how many different ways you can paint a fence. So let's look at the example. If n equals 3 and there are 2 different colors, there are 6 ways to paint. And we cannot paint 3 consecutive red or 3 consecutive green. So what we think about that, we can have integer array, right? Integer array called dp. New int n, right? And so dpi we define at the index how many method we can paint to this index. For example, the dp0 can have k ways, right? And dp1 we have k multiplied by k, right? And the third, this is dp2. Okay, so what we want to is to return dp n minus 1. Okay, so we know for every dpi, that is if we paint to index I, how many ways we can paint. It may have 2 kind of scenarios. Is that one is that the I and the I minus 1, those fence, those posts, they have the same color. If they have the same color, that means the I minus 2 and this, they should have different colors, right? So we know if we know how many methods will paint to I minus 2, then for this kind of combinations, they have the same color. So there are I minus dp for I minus 2 multiplied by k minus 1 different ways. Because for each post, we can select k minus 1. We know they cannot be consecutive. That means for the post, which is I minus 2, and also I minus 1 and I, they should have different colors, right? So these are the same color, but this and this, they are different, right? So that means for each post, we'll have k minus 1 different selections for the next to get this and this different. But this is in this case, that is, these posts have the same colors with the previous one. Okay, another scenario is that for DPI, they have different colors in previous one. So this is simple. For each post, they can select one which is different than the k minus 1 selections. So that is, so we know dp I equals dp I minus 2 multiplied by k minus 1 plus dp I minus 1 multiplied by k plus 1. Right. So this is the color is the same as the previous stick. This is different, right? But this one, as they're different, so we know there will always no consecutive. And for this one, if the same, that means they should not be the same with previous, right? I minus 2. So that we have this and have a k minus 1 selections. So this is our transition function. So let's begin to write code for this. We'll see as every stick only depend on the previous the post and the previous stick. So we can use 3 variables, right? So we'll say if let's also say that n is greater or equal to 1, right? So if n equals to 1, we just return it. And if I equals 2, we return a multiplied by k. So we can have int first equals k, second equals k multiplied by k. So we'll have int I so k there are in post. So if I from index I equals 2, I smaller than n, right? I plus. At the beginning we'll have in the third, okay, so was there. We'll say third equals first multiplied by k minus 1 plus second multiply k minus 1. So in this case, this is the same color with the previous one. This is different, right? So we can just have a first plus second. And what we need is that we need a first we'll move 1 to the next, right? Equals second. In the second equals to third. In the end, we just return third. The time complexity will be O in space is constant 1.